Hello,
Hi,
I'm Erin.
and I'm Eugene.
Today we are going to review adding and subtracting fractions. This is another video in Unit 1 before starting 6th grade math, in the second theory video. Let's start. So when you add or subtract fractions, the denominator of the fractions needs to be the same, right?
Yeah.
So if we add 3/4 to 1/6, what would you do first?
Normally to get the least common denominator, I would do 4 times 3 and 6 times 2 to get 12 for the least common denominator.
So you would make both of the denominators 12, right?
Yeah.
So now that we've made both of the fractions have a denominator of 2, we have to have the numerators proportionate to that, right?
Yeah.
So since we multiplied 4 by 3 to get 12, we would also have to have 3 times 3 to get 9, right?
Yeah.
And since we did 6 times 2 to get 12, we would also have to do 1 times 2.
Yeah, to get 2.
So now we would add the numerators. So 9 plus 2 is 11, and then keep the denominator.
Mm-hmm.
And you're probably familiar with that already, right?
Right.
So now we're going to get into more challenging problems, and I'll give you tips on how to make it easier.
Okay.
Now, what if we had to do 5/18 minus 1/30? What would you do first?
I would normally do 18 times 30.
To get the common denominator?
Yeah.
Okay, that would work. But doing 18 times 30 wouldn't be the least common denominator, right?
Right.
So, and I always suggest using the least common denominator when we're adding or subtracting fractions because it makes us deal with smaller numbers and it's more easy that way. But finding the least common denominator of 3/18 and 1/30 might be a little bit hard, right?
Right.
So I'm going to teach you 2 ways to make it a little bit easier. So the first method I call the division method, and you'll probably see why in a few seconds. But first, you write down the numbers that you want to find the least common multiple of. So in our case, it would be 18 and 30. So I would write them side by side like this. Now I'm going to draw what looks like a flipped over long division sign. And it would look like this.
Right, like a weird L.
And now we're going to divide the two numbers by a common factor that they have. So what's a common factor of 18 and 30?
2.
Yes, so you would write down 2 right here. And you would say, what's 18 divided by 2?
9.
9. And what is 30 divided by 2?
15.
15. And you write it underneath, like this. And you do this until you can't divide the two numbers that are below the long division sign. In other words, when the numbers that are at the bottom are coprime. This means that a set of numbers' greatest common factor is 1.
Right.
So when we can't divide anymore.
Mm-hmm.
But in this case, we would still be able to divide, right? 9 and 15.
Mm-hmm.
So what's another common factor of 9 and 15? Or what can we divide them both by?
3.
3. So I would draw another long division sign and write 3 here. And I would also say 9 divided by 3 is
3.
And 15 divided by 3 is
5.
5. And now we can't divide them anymore, right?
Uh-huh.
So now we would multiply the common factors that are on the left and the bottom row in an L shape. That looks like this. And I would do 2 times 3 times 3 times 5. And this would be the least common multiple of 18 and 30. So what's 2 times 3 times 3 times 5?
First, I'll do 3 times 3, and it would equal 9. And then I'll do 2 times 5, which should be 10, and then do that. And then do 9 times 10, and it would equal 90.
90. So 90 is the least common multiple of 18 and 30. Now, why does this work? The numbers that are on the left are all common factors of 18 and 30. So right here, since we divided 18 and 30 by them, right?
Mm-hmm.
And if you think about it, if we do 2 times 3, which we both divided 18 and 30 by, it equals 6.
Right.
And 6 is also a common factor of 18 and 30, right?
Mm-hmm.
And the ones right here at the bottom are all unique factors of their original numbers. So 3 to 18 and 5 to 30.
Mm-hmm.
So they don't overlap with
Right.
the common factors.
Mm-hmm.
And if you think about it, the least common multiple of 18 and 30 have to be a multiple of 18 and 30.
Right.
So the common denominator would have to be something times 18 and something times 30 at the same time.
Mm-hmm.
So what this method does is keep the numbers multiplied to a minimum.
Mm-hmm.
So if you see it this way, we already said that 2 times 3 is 6.
Right.
So we can rewrite the equation to 6 times 3 times 5, right?
Mm-hmm.
And it still equals 90.
Mm-hmm.
If we look at this, 6 times 3 equals
18.
18. And
6 times 5 is 30.
yeah, you already did it. 6 times 5 equals 30. So this also equals 18 times 5 and 30 times 3.
Right.
Like I said before, the least common denominator has to be both divisible by 18 and 30.
Right.
And this does that because we're multiplying the greatest common factor of the two by the ones that are unique to them and don't overlap.
Mm-hmm.
If you know what that means.
Right.
So if we go back to the question that we were answering, the least common denominator of the two would be 90, right?
Right.
Minus 90. And like we said here, we did 18 times 5. So we would also do 5 times 5 to the top. So 5 times 5 is 25. And then since we did 30 times 3 over here, we would also do 1 times 3.
Uh-huh.
And that equals 3.
Right.
And we would subtract the numerator, so it becomes 22 over 90.
Right.
And if we simplify that, it would be 11 over 45.
Right.
So that's the first method. Now we're going to move on to doing the second method. So I'll organize this a little bit. So in the second method, we use prime factorization. What this is doing is simplifying a number to a set of prime numbers that equal the original number when multiplied by each other.
Okay.
For example, if we prime factorize 12, that would be 4 times 3, right?
Right.
But 4 isn't a prime number, so we would divide 4 again by 2. And we would get 2 and 2.
Mm-hmm.
So 12 is equal to 2 times 2 times 3.
Mm-hmm.
That's essentially prime factorization, and we use it in this method.
Mm-hmm.
So we prime factorize the two numbers that we have. So let's do that real quick. What is 18?
6 times 3.
6 times 3. Now 3 is a prime number, but 6 isn't.
Mm-hmm.
So we would divide 6 again, right?
Mm-hmm.
By what?
3 times 2.
3 times 2.
Mm-hmm.
So we would get 18 equals 3 times 3 times 2.
Mm-hmm.
If we go one step further, we would use exponents.
Right.
3 to the power of 2 times 2. And then 30. What is 30?
10 times 3.
10 times 3. 3 is a prime number, but not 10. So we would divide 10 again.
Into 5 times 2.
5 times 2. So we would also be looking at 30 equals 2 times 3 times 5. Right?
Mm-hmm.
So now we line them up into... So now we line them up. And it would look like this. So I would do 2 times 3 to the power of 2. 2 times 3 times 5. And I would draw a line.
Mm-hmm.
Also, you would rearrange the numbers so that each number lines up with another. That each column is one number.
Right.
So that each column is the same number. So
Right.
2 and 2, 3 to the power of 2 and 3, and then 5 is just 1.
Right.
Now you would bring down the highest number of each column. So 2 and 2, they're the same things, so you would just bring down 2. Times 3 to the power of 2 or 3.
Right.
So we would bring down 3 squared.
Mm-hmm.
And then 5, you would multiply these two by 5. What's left? And this also equals to 90, which is the least common multiple of 18 and 30.
Right. So how does this one work?
It's the same as the division method. It uses the minimum amount of numbers needed to get the common multiple. So we're actually just doing 18 times 30, like you said, but taking out the unnecessary numbers.
Mm-hmm.
Because 18 times 30, if we prime factorize, like we did here, right?
Mm-hmm.
18 times 30 would just be 3 times 3 times 2 times 2 times 3 times 5, right?
Right.
And if we did this, we would end up with 2 squared times 3 to the power of 3 times 5, right?
Right.
So that would take out one number that we don't need, which makes it a smaller number.
Mm-hmm.
And we know that 3 to the power of 3 is divisible by 3.
Right.
So we just take the highest one of each number. So we take the highest number, it could be either of these, of all of them, and we just multiply them together.
Right.
Do you kind of get why this works?
Uh-huh.
And this method is easier once you get familiar with the numbers. Like I would already know that 18 equals 3 times 3 times 2. And so, yeah. And personally, I included this in the review of adding and subtracting fractions because I think finding the least common denominator of fractions is the hardest part about adding and subtracting fractions. So, yeah. Equals 3 times 3 times 2. And so, yeah. And personally, I included this in the review of adding and subtracting fractions because I think finding the least common denominator of fractions is the hardest part about adding and subtracting fractions. So, yeah. And either of these methods will still work with 2 or more numbers. So if you need to find the least common multiple of like 3 or 4 numbers, you could do that with these 2 methods as well. And we are going to go over that in the next video with 3 numbers. So that's the next video. I hope this was helpful and you learned something out of it. Thank you for watching and see you next time.